All right, I've created the the YouTube link. So I'll be sharing it here and with one or two WhatsApp groups where I was added. All right, I've created the YouTube link. So I'll be sharing it. So please check the link I'm sending. For now, please don't write your matric numbers. I don't need them, please, so that people will see the messages I'm sending. I'm pasting the link many, many times. I'm pasting it many, many times. Please copy and share. I cannot start until I have up to 10, 20, 30, 40 people on YouTube. We can't leave them behind. So I'm sharing the link many, many times. It's the same link. I'm sharing it many times. So let me go to WhatsApp group 2 and share some links there. So the YouTube people must be there before I can start. Please, I beg of you, copy the link, share with others, please. I'm still pasting the link on Zoom here. I'm pasting it many, many times so that if you miss one, you copy anyone you have and paste on your respective groups with your friends, with your course mates, classmates, course governors and course reps. Please also copy and paste, please. I repeat, Zoom, it can only take 300 people, but you guys are up to 4,000. All right, so I can see people are writing on YouTube now. So if you can hear me on YouTube, please write Manchester United on YouTube, please. So once I see one Manchester United, I will start. I'm seeing Man U. I said Manchester United. Okay, okay, okay. So a minute, let me bring out the slide and start recording it. 1 minute. I'm with you. I've not started. I'm trying to share the lecture slide. I'm with you. 1 minute, please. Okay. From YouTube, if you can see my screen, please say yes. On YouTube, if you can see my screen, say yes. I repeat, I have intentionally muted everyone. And I have now given you the privilege of mute so that we will have one meeting. If I unmute, here will be Barega Market or Oshodi Market. So we need decorum and calm, quietness and silence here. So please on YouTube, write, yes, you can see my screen, and yes, you can hear my voice, and yes, you can see me. Okay, let me go check, sorry. Minutes. Let me go check. Was there? All right, all right, all right, all right. So now the next thing is to start recording. Bear with me. I'll record it by myself. No need sending me a request to record. Okay. So record now. All right. 1 minute. Good morning, class. Again. This lecture is being recorded on cloud. We have just 300 people on Zoom, and the majority are on YouTube. And I've purposely muted everything so that you can only hear my voice. My name is Dr. Nwohiri from the Department of Computer Science. And I'm one of the lecturers that will take you through this course called Introduction to Computing Science. The major course code from our department is COS 101. Before some of you were born, it used to be called FSC 103. Then from FSC 103, just recently, it was FSC 113, but now it's COS 101. I'm still yet to understand why some from the management sciences, that's the Faculty of Management Sciences, theirs is AMS 103, but it's still the same. No difference. Still the same course, absolutely the same course. Now I'll be taking you for hopefully 3 weeks. That's 3 lectures. I want to believe that the first lecturer, Dr. Gude, had 3 lectures with you. Can someone on Zoom write yes? Let me be sure, because I named my own as lecture 4. Okay, so assuming that he has done lecture 1, 2, 3. So mine will be lecture 4. Office hours, when can you see me? You can see me anytime. However, there must be an appointment. Some of you might know my face. I am the deputy director at CITS. And some of you might not know CITS yet, but those that had issues with registration, I cannot register, I cannot pay school fees, my account has not been activated. Maybe 1 or 2 times you must have been at CITS and see my face. So I stay at CITS most of the time. My office is at Computer Science Department, but most of the time I stay at CITS room 215. Please, you cannot just come and knock at the door, so I want to see you. You must, book an appointment because it's a public office. You can write on WhatsApp, you are so person, and I would like to see you, etc. Don't write on WhatsApp, good morning, sir. Good afternoon, sir. Good evening, sir. And you keep quiet. If you keep quiet, I will also keep quiet, because I don't know if I answer whether you ask me for urgent 2K. So if you keep quiet, I will keep quiet. Good morning, sir. Go ahead and present what you want to present. I'll definitely respond. It might not be immediately, but I will respond. Okay. Now, I know there is a manual, workbook for this course. I've not asked my HOD, but I know there is. And I believe it is under circulation now, or it is yet to be sold through the bookshop. I don't know yet. So I will ask my HOD. If you already have it, fine. If you don't have it, you will still get it. So my advice is, please make sure you get it. Please. And make sure you do the assignments that will be given on that manual, and make sure you submit to avoid stories that touches the heart. The total number of registration for this course is one of the biggest in this university, around 4,000. So nobody will have time for you when you come with your stories. Oh, I was sick. Oh, my great-grandmother gave birth to twins. Or it was raining in Ikorodu when it is purely dry season. That's why I could not come and submit. Please submit when others are submitting. And I believe submission will be through your respective course reps. So I'm not saying there is anything you're submitting now, but definitely your manual, your workbook will be submitted and will be graded. And that grade will play a role in your total exam score. Exam will be CBT, that's computer-based test, usually at DLI. Most of you, I don't know, must have known where DLI is. So that's where exams, most of your exams in 100 level will be there, most, except the specific ones that pertain to your own department alone. What else? Most of these things, I believe it must have been said when Dr. Gude took over, but I still wanted to refresh everybody's memory. What else am I missing? Yeah, questions, feel free, but due to the nature of this class, due to the fact that we are so many, I cannot unmute and so I start asking your questions. It will be a real market. Therefore, you can always send your questions through your course rep. The course rep should have my number. Send your question through them after any lecture, and I promise you it will be attended to. What else am I missing? These are, the introductory part of what we are about to start. I hope I'm not missing any other thing. So I'll try to make the course interesting. So I will be your pilot. Fasten your seatbelt. Once we take off, feel free to ask for tea or for coffee. There might be turbulence on the way, but be rest assured you are in safe hands. And by the way, congratulations on your admission. Congratulations for coming to the University of First Choice. You can go and argue with your laptop. If it is not the University of First Choice, you wouldn't be here. You wouldn't have chosen Unilag as your first choice. So wishing you all the best. God's favor, God's intervention, God's blessings as you navigate from year 1 to respective year 4 or year 5 or Idiaraba people year 6. And a special greetings to my friends from Idiaraba, most especially, not my friends from Idiaraba, but my friends that are destined to go to Idiaraba. That's the pre-med students. So I've had many things to do with pre-med since 6 years now. And as the course advisor of medical lab students, 100 level, I extend my greetings to medical lab students. I extend my greetings to MBBS. I extend my greetings to physiotherapy, radiography, etc. Try your best to make sure you cross to Diaraba. Not everybody crosses. Remember that. The last 2 sets are very, very, very lucky. For example, in medical lab, everybody crossed except 1 person. Last 2 years, everybody crossed except 5 persons. But the upper years, they were not lucky. The upper years, once you have E, once you have D, you didn't cross. The current final year students in medical lab at Idiaraba, there were 55 students when they came to 100 level. But when they crossed, 35 crossed, 15 did not cross. But it should not be your own portion. However, make sure you do what others are doing. If department is saying, take this workbook, do it, submit, take it, do it, and submit. Don't go and be complaining, they are selling it costly, this or that. Others are doing it, submitting, and it is departmental based. So nobody is like extorting you. Nobody is trying to steal from you. If others are buying it 2 naira, nobody is saying that you should buy it 5 naira. And at the end of the day, you are buying it from the bookshop to make matters easy. So make sure you submit your manual. They are very, very important, not just the exam. They are very, very important. So that's my little advice for everybody. Now, let's now move on to the agenda of today. I repeat, don't bother writing your matric numbers. For you to get the link, you must have registered. Don't bother writing your matric numbers unless you just want us to see your name and greet you. All right. This lecture is being recorded, and I will share the link. The problem I noticed among this set is you guys don't have a group where, well, a group I know where most of you are about COS 101. The WhatsApp group I am in, I don't think whether you guys are up to 200 there, but there are so many students doing it. So fine, I know that any WhatsApp group might not be able to carry up to 4,000 students. Therefore, the course reps, course governors should have a group so that's where I will send the link. I wouldn't want whereby each student is writing me individually to be sending link. I will not be able to do that if you are not a course rep. So I will share the link to this. I may or may not share my slide, but the link I will share, the recording of this lecture. All right, so I'll pick you guys on lecture 4. I have to remove my video to economize on my bandwidth and data. Lecture 4 will be on computer software and programming languages. And let me introduce it a little. What we mean by computer software and programming languages. If this class was like 10 people, 20 people, I would have unmuted and asked you, what do you understand by computer software? What do you understand by programming languages? But if I unmute and allow somebody to talk, others' microphone will also be unmuted and there will be so much noise here. So, ladies and gentlemen, computers are powerful tools. However, they rely on software to function. You know, you have like the hardware, which is your body, your skin, the stuff you see. But you have the software, which is the internal stuff inside your body. I'm now using a human being as an example. So computer software refers to a set of instructions. Anywhere you hear about software, tell yourself that it is about instructions. But then what kind of instruction? It's a set of instructions that tell a computer what to do. Computer software is a set of instructions that tell a computer what to do. So no matter how the phrase or the sentence is phrased, always look out for that as instructions or directives telling the computer what to do. In fact, not just telling it what to do, but how to do it. And I'm just giving you a summary. I've not started passing my slides. And computer software is broadly categorized into two. We will still come to that. I'm just giving you a summary. Computer software is broadly categorized into two: system software and application software. We will look at what system software is. We will look at what application software is. That's number one. On your screen, you're also seeing a word there, programming languages. Now, guys, to create software, we use programming languages. These languages are structured ways of giving commands to a computer. That's the programming language. They are in a kind of structured, and they are ways of giving commands, you see, instructions to a computer. I hope we are following. They vary in complexity and purpose. There are so many programming languages there. You have those that are beginner friendly, like Python, to more complex ones, like C++, Java. Don't worry, guys. I'm still giving you introduction. I have not started changing my slide. So whatever you are seeing on the slide, it is what I'm showing you. Now, understanding programming languages is very, very, in capital letter, very, very essential for software development. You can't develop a software without understanding programming languages, and you cannot develop a software without using programming languages. Because these languages, they enable us to design applications, automate tasks, and solve problems efficiently. So in this course, guys, you will explore the basics of software and programming. We'll learn how computers interpret code, well, on the surface, and write simple programs using fundamental programming concepts. So the writing of simple programs will be handled by the next lecturer after my 3 weeks. I think that's Dr. Lucky. He will be the one to handle, writing of simple programs and fundamental programming concepts. All right. Now I am changing my slide 2. And I believe people can see it. Please, if you can see it, say yes on chat, please. Okay. All right, thank you. So I repeat, no need writing your matric number, please. You guys are young. We know the game very well. We know it before you. We know where the dead bodies are buried. People will write their matric number, disappear. Some people who are, show the market, selling goods, but they will write their matric number so that SAR will be deceived, thinking that they are here. So I don't need your matric numbers and your names. Don't bother with them. All right. I've said that computer software is a set of instructions that tells a computer how to perform specific tasks. So telling a computer what to do and telling it how to do it. And, software enables you and me, the users, to interact with the hardware and complete various functions. Because of software, if you move your mouse pointer will move. Because of software, if you type something on your keyboard, you will see it typing on your Microsoft Word. Because of software, you are able to draw something on your laptop screen. Because of your software, if you say something on the microphone, you will hear it on the speaker. Because of software, when you play FIFA game, Arsenal versus Liverpool, if you play shots, the ball will move as if it is also a shot. If you stop, that tiny something I see on the screen will also stop. If you move with the ball fast, it will move. This is thanks to software. Software is telling the system what to do and how to do it. So as I've told you, software is written in programming languages. There are many examples. I've mentioned Python. I've mentioned Java. I've also mentioned C++. Now, one other thing I want to introduce, which is darkened on your screen, bolded on the screen you are looking at, that software is executed by the central processing unit. It is executed by the central processing unit. What do I mean? We say that software is a set of instructions, abi? So that's instructions. Who is going to execute those instructions? It is no other person but the CPU, central processing unit. So the central processing unit performs or executes instructions contained in the software, and it's executing it because there is a task or more than one task to perform. Some software is pre-installed. As in when you buy your laptop, when you buy your system, when you buy your phone, or when you steal a phone, you will see some software already pre-installed there. Example is operating system. If you have stolen a phone before, me, I have not stolen. I don't know for you. If you have stolen a phone before, you will see that the operating system is already there. Android or what do you call that of Apple or Windows, iOS, it's already there. You wouldn't steal a phone on it, it will not on. But if you have stolen before, Sha, and the phone is not on, you can raise your hand. Let's recognize you. So some software are pre-installed, while others can be downloaded and installed by users. And I can bet you most of those that can be downloaded and installed, you know them, most of them. Look at it, open your Yeye phone, look at the apps there. A quarter of it is likely to have been downloaded by you and installed. Calculator is an app there, Photoshop apps, photo editing apps, name them, all kinds of apps you have there on your phone. You have your banking app, UBA Assets. You are the one that downloaded it. When you bought the phone, it was not there. Your Google Map, your Truecaller, your calendar, camera. Okay, camera is in pre-install. So I'm just trying to tell us that some software are pre-installed, while others can be downloaded and installed by you, the user. Then the last sentence on your screen, I want to also talk on that, is algorithm. Computer science students will be dealing with algorithms from year 2, year 3, year 4. And as you rise, it will be harder and harder and harder. So in this level now, you want everybody. So we scratch it on the surface. Algorithm is simply a step-by-step set of instructions. It gives you an orderliness. Do step 1. After this, perform the following, then perform this third action, fifth action, sixth, seventh, etc. So it's simply a step-by-step set of instructions. That's an algorithm. And those instructions are followed by a computer to complete a specific task. Okay, let's take an example. Think of an algorithm like a recipe for cooking. Those that like cooking, if you want to cook amala or the soup part of it. So don't laugh when I start mentioning the components. Gbegiri, ewedu, and stew. I guess I pronounce them well. I know that there are, let's take one, just ewedu. I believe there are step-by-step instructions on how to cook ewedu. You don't put everything inside. So that step-by-step is an algorithm for cooking ewedu. Same here, that algorithm is a step-by-step set of instructions that a computer will follow to complete a specific task. The specific task, for the example I gave you, could be cooking soup, but then in our own case, it could be many things. Let me just tell you one that will surprise you. If you speak on your microphone, you will hear your voice on the speaker. There was an algorithm there that was able to convert that your voice to be sounding very, very loud. That you are able to hear me here on Zoom. There is a software, which is Zoom, that comes with instructions that tells Zoom that if I say something or if I appear on the screen, take so steps. That's the algorithm to make sure that the receiver, you, the listener, would see me clearly and hear me clearly. So, and I gave an example that let's take a recipe for cooking. Now, a recipe has a clear set of steps to follow. If you follow the steps correctly, you get your desired outcome. That's a tasty meal. And if you don't follow the instruction, you might get God knows what. So different recipes exist for different dishes. Just like different algorithms exist for different problems. So in computer programs, ladies and gentlemen, an algorithm is used to solve a problem. It is used to what? Solve a problem. Read my lips. An algorithm is used to solve a problem or perform a specific task efficiently. You guys know search engines, for example, Google. So Google uses an algorithm to find the most relevant web pages based on your query. So if you type on Google, how to miss class and still pass the exam, maybe Google might say something, or in today's ChatGPT might tell you something. It is using an algorithm. That algorithm is like, okay, if I see so word in your query, I should focus on this word first before this word. How to pass exam without attending class. Maybe the query the algorithm might first concentrate on how to pass exam. It will list everything to itself, not to you. It will now look at missing exam consequences. It will now map them to give you a good answer. Okay, so I think for now I've done kind of justice to what computer software is, what algorithm is, and what executes those instructions, which is the CPU. Well, so before I leave this screen, I want to give another example that just came to my mind now. If you want to sort a list of numbers from smallest to largest, let's say you have numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but they are scattered though. Maybe 8 came first, 7, then 2, but the total is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You want to sort it from smallest to largest. An algorithm will tell the computer exactly how to do it, step by step, until the numbers are in order. So, for example, let me just tell you what the algorithm might look like. Let me write something on the screen. We use red pen. I write out all the numbers for, pardon me, I'm a great artist, 4, 6, 0, 5, all the number from 0 to 10, 9, 3, 1. Have I 1, 2, 3, 4. Oh no, I'm reaching 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. So let me leave it at this. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've written something twice here. Okay, no, everything is correct. Now, if the system or the computer is to sort these numbers from smallest to largest, let me just give you one possible algorithm it can use. There are so many algorithms. Now watch. Since you have listed the numbers, of course, we start from the first number. So it will compare. Compare first and second. So those that are not computer science students, just watch how computer thinks. 4 and 6, we compare, okay, get the first number, it has gotten the first number. Compare the first number with the next number. Which one is smallest? Place it first, etc. So let me do it. 4 and 6. 4 is smallest. 4 has been placed. So let me use another pen. 4 has been placed. That's step by step. The next, go to the second number, 6. Compare 6 and 0. Which one is smaller? Oh, no, sorry. I'm using a higher algorithm. Let me use simple one. Now see, let's start again. Compare, take the first number and compare with all the numbers. And be, interchanging their positions. Now see what I want to say. 4 and 6, which one is smaller? 4. So 4 does not interchange position with 6. You now compare 4 and 0. Which one is smaller? 0. 0 comes in front of 4. I hope I'm communicating them. 4 and 5. Which one is smaller? 4. 4 is still after 0, but before 5, etc. After that, you pick the next number. There are many ways, you can write a step-by-step way to sort these numbers. And that many ways is what I'm calling algorithm. So an algorithm is just a set of instructions that helps a computer solve a problem or complete task efficiently. So let's move on to the next slide. Characteristics of a good software. Please, there is no need writing your matric number. So somebody taxation writing her matric or his matric number on Zoom. Please, no need writing your matric numbers. So before I move on, I love people on YouTube than people on Zoom. Zoom are privileged people, only 300. YouTube is many. So a minute, let me stop the slide so that I can go check on YouTube whether everything there is going on well. Okay. All right, please, if you're on YouTube, say, write Chelsea. Please. Be sure you are hearing me. All right. Thank you. I've seen the first Chelsea. And by the way, I'm a Chelsea fan. So, Man U make una go rest. And the latest found Arsenal. All right, that's by the way. It's a joke. So, characteristics of a good software. 1, functionality. So I will speak to them briefly, one sentences or 2. Functionality. If a good software should perform the task it was designed for correctly and efficiently. I can't pick a calculator, type 2 plus 2, and it's giving me 23. Then it's not a good software. That means the instructions given to it are incorrect. So in terms of functionality, that software should perform the task it was designed for correctly and efficiently. I can't pick my banking app. I want to check for my balance. And when I log in, what I'll be seeing is video, DSTV. So it's not doing what it was assigned for correctly. That's number 1. Number 2 on your screen is reliability. The software should run without crashing or producing errors frequently. You should be able to handle unexpected situations gracefully. You don't take your app and it is always giving you a headache. It could sometimes, but not frequently or, often. So that software should be reliable. Usability, number 3 on your screen. The user interface. When I say user interface, is the software, the part you are seeing on your screen. Like you take your smartphone And let's say, which app will I mention there now on your smartphone? Let's say Netflix app. You click on it. Whatever you are seeing on the screen, whatever you are interacting with, the clicking, you see here, you touch. That's the interface. That's what I mean by interface. So usability, the number 3 on your screen, is saying that the user interface should be easy to understand and navigate. You will agree with me, there are some websites or web pages you visit, it is so complex. You don't even know how, where to click, what to do. You have in mind what you came to do, but you don't know how to navigate through. While there are some that are very user-friendly, very intuitive. Once you log in, even if it is the first time, you're able to navigate your way smoothly. So that is what we call usability. Easy to understand and navigate. Users should be able to complete their tasks with minimal effort and learning. You don't come to your app to start learning, sweating on how to use it. And most bank apps are good, have good usability. Once you log in, you already see stores like transfer, pay for data, send credit, etc. Number 4 on the screen is efficiency. The software, if it is a good software, should use minimum system resources. What I mean, it should not consume too much memory. It will not be taking too much space on your phone or your laptop. And CPU too, computer brain. There are sometimes when you're using your laptop, it is hanging. Sometimes it is caused by the fact that the CPU is so busy with so many tasks that it could not complete yours. So you have to wait and it is hanging. So the software should be efficient enough. That is, use minimum system resources. And examples of minimum system resources are the CPU, the computer memory, and the storage. As it is using minimum system resources, it should also maintain good performance. The software should run quickly and smoothly without unnecessary delays. All right, the next on the screen is maintainability. I think this word is self-explanatory. The code should be well structured. This now for the programmers. The code should be well structured, documented, easy to modify for future improvements or for bug fixes. Want to fix a bug or a problem or an error, it should be easily done. So the developer, should be able to update and enhance the software with minimal efforts. The next is portability. Something is said to be portable. In English language, portable means it can be moved from one place to the other. But when you are saying that a software is portable, what do we mean? It means that the software should be able to run on different devices and different operating systems with little or no modification. I will explain. I said in English, portability means can move from one place to the other. So in this context now, portable software means that software should be able to run on different, so that different means moving it, different devices and operating systems. Not that you get a software and it can only run on your Android phone, it cannot run on iPhone. Or you get one, it can run on iPhone, but it cannot run on Yeye Techno, etc. So it's that if a software is said to be good, then it should be able to run on different devices and operating systems with little or no modification. We wouldn't get a software that say, it's only for mobile phones, it cannot run on laptops. It should be able to, for us to call it a good software. And I'm not saying that all softwares meet these criteria. No, there are some that are not portable. They are still software, etc. Next on the screen, second to the last, security. The software should protect user data from hackers, from viruses, and unauthorized access. I know some of us will faint if they wake up and the school fees your papa paid into your account to pay in school has disappeared from your account. It is not our portion, but if it happens, some of us will faint. Or you wake up, that big money you have in your account for your business has disappeared. That means hackers maybe gained access and, swallow the whole money. So software should be able to protect user data from such incidences. You should have proper authentication. Who is logging in? How do you allow the person to log in? Is it just by password, or would the person require to do face recognition or thumbprint recognition Is there any encryption? Is there any other data protection mechanisms to make sure that you and only you can log in, or someone you authorize can log in? The last but not the least is testability. The person that is saying that Android users on they suffer, it is not true. That shows your understanding of Techno. Techno uses Android, but not all Android phones are Techno. I guess you understand that. The almighty Samsung phones, they use Android. So do you say that Android people, you are suffering? Is your own not a Nokia phone there? If we ask you now, your own might be Nokia even. All right, so please, Android is an operating system, and we are going to do operating system in the next 2 slides now. And different phones can use that operating system. So for Android, you have Nigerian Techno, but you have other big guys like Samsung and the rest. Then when you come to iOS, iOS is also an application, an operating system used by Apple. You have Windows used by Windows devices, Microsoft devices. All right, the last, please. Sorry for the little deviation. Testability. The software should be easy to test so that bugs and issues can be identified and fixed quickly. So, ladies and gentlemen, a good software system balances all these characteristics. There must be a balance. You can't have a software that has everything 100% perfect. So it balances all these characteristics to provide a smooth, efficient, and secure experience for both users and developers. All right, before I move on to the next slide, okay, I just looked at what someone wrote. You see, because people are writing matric numbers, it makes me not even come to chat to see what people are writing. Someone asked, can we also add good UI, UX? UI means user interface, user experience design under usability. You can add user interface. User experience is more or less no more about the interface. So, but user interface, yes, usability, user interface, that's what you are seeing about that software. When you log in or when you open that application on your phone, on your laptop, whatever you are seeing, can you easily navigate through the website? Can you easily go to students portion? Can you easily go to school fees portion? Those kind of things. If yes, then fine, user interface. But user experience is the general joy, I put it that way, you gain from using that app. So, well, if you can, if I have 2 software, one, I feel very good, confident using it, then I will call it a good software. But if the other one is very headache every day using it, then that one cannot be a good software. Well, so theoretically, UX and UI can be considered when you are talking about usability. So for those that don't know, UI means user interface. UX means user experience. All right. Last question I'm picking. Testability. Someone said I should explain it well. I said that a software should be easy to test. What do I mean test? Well, if you are not in the programming business, you might not understand, but English language test, what do I mean? If I want to develop a software, let me say calculator. I just woke up, I want to write a program that will create a calculator. After I've developed it, I will not start going to sell it, going to advertise it on the market. What I mean on the market is online markets. You know what I mean? Where you download your apps. Now, will I just go in there and advertise it? No. I will have to first test it. I will pay some people they call testers to test it. What do I mean? Test my calculator, whether it's doing what a calculator should do. 1, check square root of 2, what will it give me? Check square root of 4, what will it give me? Check 5 times 3, what will it give me? Check 1 plus 2 divided by 3 times 5, that's board mass, what will it give me? So if these are tested and everything is fine, good. So testability means easy to test. So if I call a tester and they are really struggling to do that, then that is not a good software. That's number one. Then number two, if there is an issue with that software and users are all making complaints, the vendor, the owner should be able to quickly interrogate, troubleshoot to find the issue and fix it. If the vendor is not able to do this quickly, then it is not a good software system. Okay, so that's it. All right, so we move on to the next slide. Okay. Please, one question. Can you tell me the Premier League table, which level is Manchester United now? Are they 14, 15, 16? Which position? You two people, come and tell us. 60. We, Chelsea, that are making mouth every day. Are we in first position? No. Are we in second? No. But I'm happy that we are higher than Manchester people. I hope I'm right, so that we are higher than Manchester people. Manchester people, that's Man U and Man City. Most of you guys were very young when Man City were trying to overtake Man U. But try and watch on YouTube, like 10 years ago, there about 10, 11 years ago, when Manchester was red. Then Man City came in with big money. They bought so many, and they were still flopping for 1, 2, 3 years. Then gradually they took over, and Manchester became blue. We were so happy. But man, they let the table now turn against us. They were now winning us, winning the Premier League. But inside of we are still happy, Sha. Now it's not red. All right, I've teased you a lot. So let's move on. Look at the screen and stop writing. The same computer software. So this diagram you're seeing is trying to show you how I'm going to navigate now. I will first talk about system software. I will now talk about application software. So at the beginning, during my introductory statements, I said that computer software is broadly classified into system software and application software. And this classification is purely based on their purpose and function. So what is system software? And which is the most important software actually? They are by far more important than application software. So this type of software manages the computer's hardware and provides a platform for other software to run, including the application software. So without system software, application software will not work. System software works in the background and helps the computer function properly. Examples, you see it on the next screen, but I will mention it here. Operating systems, they are system software. Don't confuse. There was a test that was confused. What's the difference between system software and operating system? System software is the general name. Under it, there are many examples. One of them is operating system. Another one is utility programs. We are going to see the next slide. Examples of operating system I've mentioned them: Windows, Linux, Android, Mac OS, iOS, etc. Utility programs are there. I will give an example as we go. Now, the second on your screen is application software. Most of you know application software by far more than you know system software. The application software, it is also called apps or applications. It's designed for users to perform specific tasks, like writing, playing games, browsing the internet. So examples like word processing software like Microsoft Word, Google Docs. You have your web browsers, example, Google Chrome, Mozilla, Firefox. You have others like games and media players. Games, now you know Call of Duty. You know media player like VLC, etc. So this is an introduction now. Now in the next slide, we are going to look at system software deep. After that, we now look at application software deep. So let's move. Next, system software. I cannot be defining what I'm defining many times. Someone is saying I should define it again. Remember, I'll give you the slide, remember, I'll give you the link to this recording. System software now, I said it's a type of computer software, right? That is the slide again. Yeah, it's a type of computer software that manages hardware and provides essential services for other software applications. to put it short, there are software that manages hardware, one, and serve as a platform for other software, including applications, to function well. So they manages the hardware and serve as a platform for other software to run. So without system software, application software will not run. Okay, I'm now on system software, Gongom. And you can see little definition I wrote there. It runs a computer's hardware and application programs. So the application programs run on system software. Remember, one example of system software is operating system. Without your own Android, your phone will not even turn on. Talk less of you accessing other applications on your phone. So that's what we mean that application programs rely on system software to function. So it manages hardware and provides essential services for other software applications to run. So, and system software acts as a bridge between computer hardware and the user. Let me give you as an example of system software serving as a bridge between you and your hardware. Let's take one hardware, keyboard. If the operating system is not there, if you type, my name is Aisha, nothing will type on your screen, nothing. If you type, I like sleeping, I don't like going to class, nothing will type. The reason is that the system software is not there. So the system software is the intermediary, the middleman between the user and all other hardware. Please note, in silent voice, when we say user is not always only the human beings. Other applications can also serve as user. If an application is trying to do something on the system, it is the system software that is in between that application and whatever it is trying to access. So the user can be human, can be also other application, but at the middle is system software. Key features of system software. One on your screen, manages hardware. What does it mean? The system software controls and coordinates hardware components. Like I've been calling keyboard, but there are many other hardware I believe you must have done with Dr. Gude. The hardwares can be CPU is a hardware. The memory, that's your RAM, random access memory, is a hardware. Storage devices, hardware. Peripherals like mouse, like attached printer, and etc. They are all hardware. So that number one, manages hardware, means that the system software controls and coordinates the hardware components. Number two on your screen, provides a platform. So system software allows applications to run smoothly. Without system software, your apps on your laptop, on your desktop, on your smartphone, on your tablet will not run or will not run smoothly. Third on the screen, you see, which is very important, the third one runs in the background. Most system software, they run in the background. Unlike your application software, system software is always running behind the scenes. You are not seeing your operating system. You are not seeing the antivirus system. You are not seeing your utilities, which we'll look at the examples. But what you always see is your apps, your applications. Last but not the least, is essential for functionality. That's a computer cannot operate without system software. That is full stop. It cannot operate without system software. So, no, you are not dropping any attendance. Don't write your matric number, nothing. Just keep all of them to yourself. If you like, don't attend the class. If you like, attend the class. But there are consequences. If you don't attend, questions I said, I know what I will say. I know what I'm saying with my mouth. That's what I'm going to say mostly, not what you're seeing on the screen. So don't relax in your house and say, after all, the man will give us slide. Okay. All right. Now on the screen, there is also a diagram. This diagram is purely to show you how I am going to move. Under system software, the next slide will talk about operating system. After that, the next slide, we talk about utility software. After that, the next slide, we talk about language translators. So I brought this diagram here so that you will not get confused along the way. I can go one slide back to show you how we started. This is how we started. System software. I'm still in system software. I've not gone to application software. So the next slide, I'm still in system software. I've talked about features of system software in general. Now I'm going to talk about these three, starting with operating system. So the next slide will be operating system. And here you have it, operating system. So an OS, that's the name I will be using now, is software that acts as an interface between computer hardware and users. It manages computer resources, such as memory, processing power, storage, and ensure that different programs run smoothly. All I've just said now, I've said it before. So why is an OS very important? Let me give you a typical short example why an OS is very important. Imagine a computer as a car. The operating system is the driver. It controls how the car moves, stops, interacts with the environment. Without a driver, ladies and gentlemen, the car or the computer in this case wouldn't function properly. You will agree with me. So if you start your papa's car, nobody is there and you put it like to start driving, it will crash. But if the driver is there, the driver will ensure that the tire turns right when you see the road turning to the right, or the tire turns left when you see the road turning to the left, or it brakes. These are all hardware I'm calling now. I've called tire. I'm now talking about brake. It brakes when somebody is passing or when it comes to a red light, or the car horn when something is blocking it, etc. So yes, someone will say, Sabo, today we have a driverless cars in US, all the cars that go without driver. Yes, but you have a software there doing the job of the driver, which is the operating system, you know. Okay, so in summary, an OS is essential software that manages the hardware and software resources, and it acts as an intermediary between the user and the machine to run applications and perform tasks. Which tasks can it perform? File management, memory allocation, controlling input and output devices. Input and output devices, you guys should know what it is by now. You have input devices like keyboard, like mouse, like which other one? Scanner. Scanner is inputs, right? Yeah. Wait, so is scanner inputs? I know that printer is outputs. Scanner should be inputs. Correct me, Shai, if I'm wrong. So these devices and also output devices like monitor, like speaker, etc. The what? Operating system controls them. Memory allocation, uncle. As your laptop is on or your mobile phone is on, there are so many processes running at the background that you don't know. What you know is what you are using. But there are many processes running at the background to ensure that you are enjoying what you are doing on your laptop. So the operating system ensures that those behind the scene tasks are allocated memory. My language, you might not understand when I say memory is allocated. Okay, let me explain it a little more. For a CPU, brain of the computer, to do something, it must go to the memory to pick that. And when I say memory, I'm not talking about your storage devices. I mean your random access memory, the volatile memory of the system, RAM. So if you want to watch video, for example, that is stored on your hard drive or on your flash drive, CPU doesn't start playing the video from your flash drive. But yes, you might think that's what is happening. No, what is happening is that when you click on that video on your flash drive, the CPU will take it and put it in the memory first. So it is from the memory, it now plays it. Yes, your copy still remains on your flash drive, on your SSD, on your hard drive, but what you are doing at the moment is coming from the RAM, random access memory. So when I say that the OS allocates memory, that's what I mean. So many tasks, so the OS knows how to put them to the memory and assign them spaces in the memory. That's the job of the OS. And thanks to that, you're able to do many things on your system at a time. There are functions of the operating system, the last sentence there on your screen. Process management, by that I mean it handles multiple programs running at the same time. Second one, memory management, I've also said it. It allocates and deallocates memory for programs. The third one on your screen is file system management. By that I mean that the operating system organizes, stores, and retrieves files efficiently. The files you stored on your system, or the files that are stored inside the system already. The OS ensures that they are organized, efficiently stored, and retrieved. The next is device management. It controls hardware like your printers, like your USB drives, keyboards, and the rest. And the last on your screen is user interface. The OS provides a way for users to interact with the computer, e.g. your Windows, your Mac OS, your Linux. These are all interface of the operating system. So the next, I will go to types of operating system software. So this you have to listen carefully, but I will have to be pretty fast to explain what each generally is doing. Okay, before I go on, someone asks, what is the difference between system software and operating system in definition, since both serve as an interface between the user and the computer hardware? Well, good question. I always try to answer a question by using a real-life example. Let me just use an example. So don't laugh if it sounds so primitive, but I know why I'm using it to answer the question of what is the difference between system software and operating system. It's like asking, what is the difference between a human being and a woman? Or what is the difference between a human being and a man? So from there, you see that all men are human beings, but not all human beings are men. 1 minute, please. Let me pick this call. A minute, please. All right, sorry for that little distance. So I was called in for a meeting. They say I should come now. We are doing interview for some lecturers that we want to employ. So they say they are waiting for me, but I'll be fast. Now, batch operating system. Okay, so somebody asked the difference between software, right? Operating system and the system software. So I'm saying that it's like asking the difference between human being and a girl or human being and a boy. Now, all operating system is a type of system software. System software, there are 3 types. The other 2, I've not been mentioning them. One is operating system, which you're asking me now. Another one is what? Utility. Another one is what? Translators. I've not talked about those 3, but I just talked about operating system. So if I'm defining the difference, I'll have to, if I'm defining what a system software is, I'll have to talk about operating system. I'll have to talk about translator, which I'm not done. I'll also have to talk about what the utilities, which I have not done. So I've been defining only one of them, which is operating system. That it is the middleman between users and the hardware. And I also say the same thing with system software. But the other thing system software does that operating system is not, because operating system is just a type. For example, system software helps to protect your system. Operating system is not doing that. But viruses, that's utilities can do that. Utilities are another type of system software. So at this stage, I just gave you the definition of operating system and the definition of system software. But there are more that the system software does that the operating system does not do. All right. So we move on. So please, I might not be able to accept questions now because I've been given to appear in a meeting in the next 10, 15 minutes. So I have to move fast. One is batch operating system. So batch operating systems, the concept here is that tasks are collected, grouped, and executed without user interaction. That tasks are collected in groups, in batches, and executed without user interaction. A key feature here is that there is no user interaction, and tasks are processed sequentially. Example is payroll. Like lecturers in Unilag, every month, the payroll system, which is a software, calculates our salaries. You don't have somebody sitting there every month, they are calculating salaries of everybody. No. It batches everyone, calculate the salary based on your level. You have senior lecturer, you have junior ones, you have L1, L2, senior lecturer, associate prof, professors. So it is batched. And then task is performed. The task was what? Calculating their salaries. And another key feature is there is no direct user interaction. Please remember that. The second one is multi-programming operating system. Multi-programs reside in memory, and the CPU switches between them to maximize utilization. That's in a multi-programming operating system. So many programs are in the memory at the time. So the CPU will switch from this to execute after I move to the next program to execute. Key feature here is that it improves CPU usage. And another thing is that one program runs while others wait, and it requires memory management. The early versions of Unix is an operating system with a multi-programming operating system. Okay, so just, even if you don't remember all I'm saying, you have the video to watch later. The next, multitasking operating system, it allows a single user to run multiple tasks at the same time. So the key feature here is rapid switching between processes, and it uses time sharing. Example is your Windows, your Linux, your Mac OS. An everyday example is browsing the web while listening to music and editing a document. You see, three different tasks: browsing the web while listening to music and editing a document. Number 4 is time sharing. CPU time is divided into small slices and shared among multiple users or processes. So the CPU has its time, so it allocates its time to different users and processes at a time. Example of a time-sharing operating system is Unix 2, Linux servers, and well, these are the two I can remember now. Next is multi-user. Their names are self-explanatory, actually. Multi-user OS allows multiple users to access a computer system at the same time. So in this case, key feature is user authentication. Those multiple users will have to authenticate. Then resource protection, concurrent access. Number 6 is multi-processing operating system. It uses 2 or more CPU to execute processes at the same time. Multi-processing operating systems are very powerful. So you can imagine a system using 2 or more CPUs. Most of all our laptops, our phones, they use just one. But some use 2 or more CPUs. So for key features is that you have parallel execution, more than one processes at a time. Load balancing, increased reliability, etc. Real-time operating system. Here, it responds to inputs within strict time constraints. Almost at the same time as you're inputting, you're getting your output. A very good example is your ATM machine. When you go to ATM to withdraw that your 2,000 naira remaining, others have 1 million, you 2,000. So when you go there, as you input your password, type 2,000 and want to withdraw, it will start withdrawing immediately. So you inputted, you made some inputs. Your inputs were what? Your password, your whatever, your code on the ATM machine, and the money start coming out almost at the same time. So real-time operating system responds to inputs within, strict time constraints. The key features is that deadlines must be met. You can't go type that you're taking 2,000 naira and then you go home and come tomorrow to come and collect the money. And minimal latency. Okay, then distributed operating system. It manages a group of, when you hear about distributed in computer science, it means systems are in different locations, but are working as a single system. So distributed OS manages a group of interdependent computers and makes them appear as a single system. Okay, and then last but not the least is network operating system, provides services to computers connected over a network. So if you have a network, local area network, let's say in computer science building, you have 20 computers connected to form a network. So you have what we call network operating system, that provides services to only those computer. Which kind of services? Something like file sharing, something like printer sharing. I can be in my office, click, and the printer in secretary's office will be printed. So that's the key features of that. So ladies and gentlemen, I will call it a day today. We've done enough. We had 1, 2, 3, 4, 5, 6 slides to go, but of course we'll cover. Sorry for that, because I've been summoned. So I will share the slide. I will also share the word link to this recording. Remember, the slide will contain the part I've not covered. However, I will cover them next week, Tuesday. All right? Okay. So permit me to leave. Mind you, students say, please, I did not hear you. I don't want anybody to throw stone on my head when I go outside. So enjoy your day and good luck with your journey in Unilag. Bye-bye. I will share the link, so I will take it to the WhatsApp group where the course reps also wrote. Please, course rep or anybody that gets the link and the slide, don't keep it yourself. Share it with others, please. Bye.